Is the screen visible?
Yes, ma'am.
So, so today we are going to see about translating SQL into relational algebra. Okay. So for which, what we are supposed to do first, we need to know about. First, we need to know about. First, we need to know about tables which we can create. So here, whole throughout this, they have used this. That is movie star, star scene, then movie execution as well as studio. These are all the tables which they have used and for which they have created what are all the things or the columns with what are all the names which are there with the data type which they have specified. So, okay. So what need to be there? So the first case is, so we know how to insert a table, how to create a table, then insert the values in the table, then how we can describe it, how we are going to view the elements which are there in the table or the records which are there in the table. Then we know about what are the update statement or the manipulation methods which we are using. This is what we are familiar with, right? So here comes the thing that is select star from R, comma R. So here we are having two R. Okay, R may be the one which will be describing or telling you about what is the table which we are supposed to select. Okay, so when we are selecting, what need to be there? So till now, what we saw was just what is the right? So we be providing the table name alone when we are giving select star from what is the table name. Here we are having two things need to be displayed. So for making that is for displaying the two, what we are supposed to do, we can't because both the things may be the similar one, right? So if it is the same one, it may be a contradiction that whether to have the same thing or else with the different one, what need to be displayed, that's all the contradiction which may be happening. So for in that such cases, we'll be going for having the alias. Okay, alias is the one in which we'll be, what all the things which are there, that will be the same, but we'll be giving a different name. Okay, that is the concept of alias. So we'll be giving here as select star from R, comma R, R2. Okay, we'll be having the second one as R2, so that we can distinguish what is R and the second R. Okay, that is what when we are going with this concept. And the second thing is select from where statements without subqueries. What does a subquery means? So query within a query, if we are having, that will be the subquery which is there, right? So we are having, we know about the thing that is the main query as well as subquery is there. So when we are having main query as well as subquery in a query, then we will be calling the main query as the outer query. The subquery that will be the inner query which is there, right? So here we will be having without the subqueries. What we need to provide here, okay? For which, what is the algebra we are going to define? So for which, in the statement which will be containing the syntax is select list. The things which we need to select will be providing with commas. Then from R1 till R2, T2, like this, it will be moving on from whatever locations which we are providing. Where what is the condition which be specified, what need to be the condition which need to be done. Okay, we need to check that. So for which we need to translate it into the queries. So here no subqueries is there. So we'll be giving us pi, but need to be selected, that will be given under pi, right? So the select list that is given in pi, then sigma. Sigma is the one which we use for the select. Okay, so what need to be selected here according to the condition which is given, we need to select it. Okay, so we'll be giving the condition which is there, among which we'll be giving what all the things need to be listed. Okay, from whatever ways which need to be there. Okay, so here when it is into, it will be into mark, that will be specifying you the Cartesian product. Okay, and for which we are having an example query, that is select movie title from stars in comma movie star. So both in stars in as well as movie star, we need to select the movie title, where what need to be the condition, that is star name equal to name and birth date equal to 1960. So both condition need to be met, right? Because it is given in and, it is not or. So we are supposed to translate as what need to be selected. Movie title is the one which need to be selected. So we will be giving us pi movie title. We need to select here. What are all the specific things need to be selected? That is sigma, from where, that is what are all the cases? Two conditions, right? What are all the two conditions which are specified? That is star name equal to name, and because it is and, we will be going for the intersection concept, because both the things need to be selected, right? So we'll be giving there as the intersection concept, and we have provided star name equal to name, and that is intersection birth date equal to 1960. If both the conditions are met, it will be picking up that record. Okay, so from what are all the cases which we need to check? We need to check within the stars in as well as movie star table. Okay, that is how we will be interpreting the query into its equivalent algebra. Are you getting me? So the next thing is normalizing where queries into exist and not exist form. Okay, we will be giving whether it is existing or not existing. Containing சொல்லுவோம் இல்லையா, when we are giving containing, whether it is containing in that thing or not containing. So in that specific way, here we will be providing it as exist and not exist. Okay, that is the one which we are representing here. So we will be having the SQL statement. What is the statement which we are giving here? That is select movie title from stars in. Okay, stars in table, we need to select the movie title, where star name in what is the case, we'll be giving what is the case which exists, that is select star from movie star. Okay, where birth date equal to 1960. So equivalently we can reframe as select movie title from stars in where exist. Okay, so star name is the one, okay, which we are giving. Here we are replacing that with where exist. Okay, inside which we will be giving the query. Okay, so exist in the sense which contains into that particular place. Okay, that is the meaning. So exist, select name from movie star where birth date equal to 1980, and what is the thing which is there, that is the star name is the one which will be prevailing there. So we'll be giving that as and name equal to star name. Okay, that is how we'll be reframing the query. We can also write the query in the previous form. Okay, and also we can have it in this form. Okay, so here as it is containing in that particular place, we'll be giving it as exist. Okay, so suppose we are having another query. Okay, so which is these are all the two conditions which need to be met, but other than what are all the value which is here, we need to take it. Okay, so we'll be providing that is where not exist. Okay, not exist, what is the query name and what is the place which is there. Okay, that is how we'll be explaining the case, or else we can have the same thing in this way. Okay, when it is containing in that particular place, we'll be giving it as exists, and if it is not inside that particular place, we are giving it as not exist. Okay, so here too, another thing, that is select name from movie execution, where what is the case, we'll be providing the net worth. Okay, what is the net worth which is there, that is network which is greater than or equal to all of select e dot net worth. E dot net worth is the one which need to be selected here, right? So e dot net worth from movie execution E. Now we'll be replacing it as, because we need to know about where we are supposed to give not exist, right? So in the previous case, we saw about how we are reframing the query into by including the exist, right? So here we are reframing, or we are writing in such a way that there contains not exist. So we will be providing it as select name from movie execution where not exist. What is not existing? That is select e dot net worth from movie execution, where here we are in the previous case, it is not visible. Okay, kindly bear with me. So that is the one. Yes. Okay, it is visible now. So this is how the condition. Okay. So net worth which is greater than or equal to all. Okay. And we'll be giving the case. So what is not present, that is less than, or less than is the one which is not existing, right? So we'll be giving here, we'll be changing it as, here we have given not exist. So the condition need to be reversed. So we'll be giving here as select e dot net worth from movie execution E, where net worth less than e dot net worth. Okay, so that is how we can replace by including exist as well as not exist. Okay, exist in the sense we need to give what is the condition which is there. Not exist in the sense what is the thing which need to be getting, that is we are supposed to be resulted that particular case, except than that we need to provide all the other case. Okay, here it is
Um,
greater than, yeah,
Ma'am, one doubt, ma'am.
yeah, tell me.
What is this all doing, and what is the means comparison of doing the alternate query, and what is the time and what is the efficiency that you showed in the previous slide?
Yeah.
Term be saying to be rewritten can be rewritten as
So
this query like that.
already what we saw regarding all, That is union as well as union all. In the previous lab,
Yeah,
yeah, in union, what it is doing?
it removes all the duplicates and
Duplicates,
uh,
and it will be doing the thing,
yeah.
right? But in the case of all, what it does,
Irrespective of the redundancy of the data, it joins the both the data.
join all the cases,
Yeah.
right? So here, as in the case of that is network greater than or equal to all, in the sense it will be considering all the datas, as how we saw there.
Okay, somewhat equal to union all.
Union all. So it will be considering all,
Okay.
and inside which we will be having the condition.
Condition. Okay.
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 So that is the one which is existing there. So we will be replacing here with network, which is less than or equal to, sorry, less than, because we have included equal to also there. So we had to give the reverse of that alone. So that is less than E dot network. Okay. So the next,
One to reverse, ma'am. Can you come again once?
reverse in the sense where network greater than or equal to all is the condition which we are giving. So this is the one which need to be existing.
Oh, okay, okay. I get it, ma'am.
Ah,
Okay.
ah.
Uh,
So not as exist in the sense the reverse of that.
it was
What it is not including, that need to be prevail.
okay.
Okay. So the next is consider relations R of A comma B and S of C. Then select C from S, where C in select sum of B from group by E. So in the previous cases, yeah, what is group by? Already we studied
Group
group by.
grouping the related information of a
Yeah,
data.
related information. So order by is the one which we saw in addition to that. Are you remembering this? Order by in the sense we are for the sorting mechanism we saw this.
Yes, ma'am.
Hi. So here we will be making this possible by using the exist. Okay. So select C from S, where exist. What is existing? Select sum of B from R group by A having. Okay. We need to include having, because we have included group by. Okay. So having, what is having here? That is sum of B which is equal to C. Okay, sum of B which is equal to C. So wherever, because here we have given where C in select of the cases. So that particular cases which we are assuming, and we are providing sum of B which is equal to C. Okay, can you get this? Students, are you here?
Ma'am, any real world example, ma'am?
Mm, yes, I'll tell. Wait. Ah, okay. So here we are having movie title, right? So select movie title from star. Okay. Where here they have given excess. So where C, what is C here in the case? Okay.
Movie title.
Yeah, movie title. Okay. Movie title. Yes. So movie title. Okay. Now, what is the condition? That is select sum of B from, what is R?
Stars.
Yeah, both relations. Okay, that will be RR group by A. What is A? That is the
Table.
thing, yeah, table which we have given. Okay, so A having sum of B, some condition which need to be met. Okay, so
Okay.
here what is the condition? That is birth date equal to 1960 and name equal to star name. So
Okay.
that particular condition which is there, that will be given here.
Okay. Okay, ma'am.
Are you getting?
So, is it this having class is somewhat an alternate to exist and non-exist, ma'am?
Yeah, which is in that particular place, which
Yeah.
will be telling the same, okay, meaning.
Okay.
Next is correlated subqueries or else context relation. So already we saw about correlated subqueries, right, in the lab. So in correlated subqueries, what is about correlated subqueries? Can anyone?
No, ma'am, I couldn't understand this correlated subquery. I kept it.
Okay. Fourth thing is the correlated subquery, which we dealt in the previous lab, right? So based on which, what is a correlated subquery? That is, that is what is the subquery which is there in the main, which is included in the main query. That particular subquery is dependent on the main query. Okay, the overall result of that particular query, that will be, that is the one in which the subquery which will be depending on the main query to make the overall result. Okay, so if that is the condition which is prevailing, that is said to be correlated subquery. So what we can have, that is the outer relation as well as inner relation, or the two concepts which we studied, right? So what is the outer relation or the outer query? Inner query as well as outer query. What is the inner query and what is an outer query?
Can I explain it with an example, ma'am?
Yes, tell me.
So, for example, if there are two tables,
Mm,
let us consider some restaurant orders,
mm,
which I was doing.
mm,
One table says orders,
mm,
in which each menu has a price.
mm,
So, order table has menu,
mm.
but there is a second table called price, and only that menu in the second table we have the price value.
Okay.
So we can write a query to
Mm,
get the price of each
mm,
menu
mm,
from price table,
mm.
so that that will affect the orders table.
Okay.
Sorry, that query.
Mm.
That is correlated subquery. Am I correct, ma'am?
Yeah, correct. That is the one. Okay.
Okay.
So the result of that, that will be dependent on the outer query based on the condition which is there in the inner query. Okay. That is supposed to be called as correlated subquery. Next is, we are having an example in which we will be having the corresponding parameters which are there in the previous cases. Now we will be translating the select from where subquery. So for which we need to see to that the two conditions are there. We need to know two conditions. What are all the two? We must add all the context relation to the Cartesian product of the relations in the from list. So what supposed to called as the Cartesian product? So you have told an example like restaurant which will be containing menu is a table and also price is a table, right? So we need to consider all the cases which are there in price as well as menu, right? If suppose price as well as menu, that are all the two tables which are there, and we are asking the interrelated what are all the things which are there in the query, then what we are supposed to do, we need to match with all the data which are there, all the records which are there in table 1. What is the table 1? That is price, as well as the table 2 is menu. Okay, so we need to match with all the entries which are there. So for which what we will be doing, we will be making the Cartesian product of the value which is, that is the thing which is there in sorry, what is the thing, price as well as menu, right? So price cross menu, that will be giving the Cartesian product, and we need to do when we are going with select from where subqueries. Okay, that is the first thing which we need to note. And the second thing is we must add all the parameters as attributes to the projection menu. So when we are going with the projection menu, what we need to do, we need to add, or else we need to select all the parameters or the attributes which are there in that particular table. Okay, that are all the two things which we need to make a note of it for having the translation select from subqueries, where subqueries. Okay, so now we are having the with this considerations, we are having the example. What is the example? That is select name from movie star where birth date equal to 1960 and name equal to star name. Okay, so here the condition is the one. Okay, but the thing which we need to check here is all. So this is based on, this is the one which is under select from where subqueries. Okay, so now we can translate by having the notes in our mind. So for which we'll be having the pi. Okay, inside the pi, based on the movie star, what are all the parameters which are there, we need to consider it. Okay, when we are translating. So movie title, movie year, then star name as well as name. That are all the parameters which are under movie star. So we need to consider that, and we will be selecting. What we will be selecting? Birth date equal to 1960 and also name equal to star name. So that will be a that is intersection. Okay, so we need to check with both the condition. If both the condition are met, that particular record is chosen. Now what we need to do, we need to make the Cartesian product among the tables which we are using for the same. Okay, so what are all the two tables which are involved? That is movie star as well as stars in. Okay, so we will be making the Cartesian product of the two and we will be finding the result. Okay, that is how we need to translate the query based translate the query into algebra based on the select from where subqueries. Okay, and the next is decorrelation of subqueries appearing in a conjunctive where condition. Okay, so for which the general statement which is of the form, that is the syntax is select list from list where condition. Okay, so in the case of select also we'll be having as many, not like this. Okay, only one condition is not, one thing is not supposed to be selected. We need to select a support of list, select the things which is there in the list, and the from list also we'll be having not a single that is table. Okay, it will be having a list of things which need to be uh, selected from. Okay, so that is how, and we'll be having the where condition. So in that particular sub cases, what we are supposed to do, the where condition is a conjunction of what all the select from as well as where subqueries, which will be containing maybe additional conditions, as well as it may or may not contain the subqueries. Okay, so we'll be having, and what are all the things which we need to see to that for having the uh, condition in our mind. So for which here they have told that we are translating in such a way that it won't be containing any subqueries. Okay, if it is not containing any subqueries, we'll be denoting that by using the simple, this is shy. Okay, Shy is the one which is denoted in case where we are not considering the subqueries. Okay, subquery free condition is given as or denoted as shy. Okay, now we will be having the translation which will be carrying out in this 4 steps. The first step is translate the subquery free part. Okay, subquery free part need to be translated first, then we'll be having the decorrelate the excess subqueries. Okay, we are not, that is, we'll be decorrelating the, we are not correlating, we'll be decorrelating. Okay, the reverse of that correlation, that will be happening based on the excess subqueries. Then we'll be derelating, decorrelating the not excess subqueries, then we'll be applying the projection. Okay, that are all the steps need to be followed when we are going with the translation of decorrelation of subqueries. So how we'll be making the translating the subquery free part. Okay, so when we are making the subquery free part, we'll be having an example. What is the example? That is, select star from list where, what is the subquery free part? So that will be indicated using shy. Okay, so now it is not taken, and the relational algebra expression which we are using is of the form sigma. Sigma is used for select. Okay, selecting. So in the select, we will be giving what are all the things which need to be selected, right? So here, as it is a subquery free part, we will be representing by using shy of what are all the things which is there. Okay, E. So E is the Cartesian product which is based on the from as well as the other. Okay. So we'll be considering a relation. We'll be considering the relation. Okay. What is the relation? That is, consider the following nested statements over the relation R of, that is the relation of A comma B and S of C. Okay, so we'll be providing the query. What is the query? That is, select R1 into A comma R1 into B from R R1. Okay, that is the alias which we will be providing. Okay, comma S, where X is, which will be inside the thing, that is, select R2 comma A, R2 comma B from R2, where 2 dot A, which is equal to R1 dot B and exist, inside which we'll be giving another query. So subquery within another, that we'll be having another subquery. So that is the nested subqueries. Okay.
Um,
Mm.
uh, the alias is not given for R2. There is it correct? Select R2 dot A, R2 dot B from R2, right?
Yeah, that's what they have been represented as R1, that is R2 alone, right?
Yeah.
So R underscore 2
No, but the alias syntax is the table name and alias name, right?
is R2 need to be there.
Yeah.
Yeah, okay. So where 2 dot A, which is equal to R1 dot B and exist, select R3 dot A, comma R3 dot B from the table R3, where R3 dot A, which is equal to R2 dot B and R3 dot B, which is equal to S dot C. Okay, this is the nested queries which we will be making use of it. Okay, so when we are translating, we will be providing it as select star from R2, where R2 dot A, which is equal to, no, R underscore 2. Okay, that is the notation they have given. So r underscore 2 dot a, which is equal to r underscore 1 dot b. So we are translating, this is the query which they are having. So we will be translating it into the form, that is sigma. What is selected? That is R2 dot A is the one which we are selecting, and we are checking with R2 dot A, which is equal to what is the condition which is there. Along with that, we will be providing the Cartesian product. Okay, that is the way in which we'll be providing the sub, that is nested subqueries. Next is how we'll be decorrelating the excess subqueries. Okay, so how we can do it? That is the one which is given here, that is, yeah, that will be done in this way. That is, we'll be having sigma r3 dot a, which is equal to r2 dot b, and inside which we'll be having certain case into yes. Okay, so this is one thing, and based on which how we'll be decorrelating. In the case of decorrelating, what is the condition which need to be met? That is, we'll be translating the subquery free part, then we'll be decorrelating the excess subqueries. Then if there is any not excess subqueries, we need to decorrelate that too. Then we need to apply the projection, right? So in the previous cases, they have neglected what are all the subqueries which are there. Okay, so subquery free part alone will be taken into consideration, and they have translated that into the other form, that is sigma r2 dot r2, which is equal to r1 dot b, inside which they have given the Cartesian product of 2 as well as 1. Okay, and now based on which they have translated into this form, which will be having the conjunction of r3 dot a and r3 dot b, which is equal to s dot c, which is the one which is present at the where condition. Okay, that is the condition. Then they have given what we have given as such here. Okay, as in this base they have provided it. Next is group by as well as having. Okay, so in the case of group by, we can use that too for the aggregation concept. What for we are going for the aggregation? That is, when we need to collect what are all the things which are there, for such a case, we'll be going for the aggregation. Okay, so we'll be having the select statement in which it will be containing the group by a particular column name which we are providing. Then based on that, the that is the condition is checked with. Okay, so we'll be giving the, what is the syntax is, that is select list from list, where we'll be giving the where condition. Group by, what is the group list which we are providing, having, what is the condition. Okay, so for which we can have an example. Yes, in all other cases they have given what need to be there. Okay, when it is a subquery, how we need to write it. Okay, so select star from list, where we'll be giving the condition. So for which we'll, how we'll be making the aggregation. Okay, that is what it is given here. So pi, what all things which we'll be selecting. Okay, now we'll be having the select expression which will be containing the condition, what is the having condition. And we'll be in, for grouping we'll be having the notation y, and inside which we'll be giving the elements need to be grouped, having the group list. And for making the aggregation. We will be performing aggregation list of what is the E value. Okay. And the example which is based on group by as well as having is select sum of B. Students, are you here?
Yes, ma'am.
Okay. The subquery is select sum of B from the relation R group by A. Okay, A may be the column which is there having sum of B. That is the condition. That is sum of B which is equal to C. Now we need to translate that into the algebra format. Okay. So pi, okay, what are all the things which are there in pi? What are all the things which are there? That is C. List we need to provide. So C comma sum of B. That are all the two things which are there. So we'll be giving us C comma sum of B. Now we need to have the select. Okay. In the case of select, what is the condition which need to be met? Having condition, right? So that is the syntax. So we'll be providing C equal to sum of B. Okay. Now for aggregation, what need to be done? What are all the things which are there in group by, right? So why, what is the resultant thing which is there? C comma, okay, and the thing which is grouped by is A, comma, what is the other element which is involved? That is sum of B, right? So inside that, we will be providing what are all the Cartesian product. Okay, what is the Cartesian product? That is relation R as well as relation S. Okay, that are all the two relations which is present and based on which we will be having the conditions. Okay, that is how we will be translating the subquery format based on having as well as group by. Okay. So these are all the ways in which we will be translating each and every subcategories into its equivalent relational algebra. Any doubt in this? Students?
Do we have this in lab?
Yeah, you may be having this too in lab.
Yeah.
Kindly answer your attendance. One thousand one,
Present, ma'am.
two,
Present, ma'am.
three. Elia Emmanuel. Not here.
Present, ma'am.
Okay.
Present, ma'am.
1004. Yes.
Present, ma'am.
1005. Ashwin.
Present, ma'am. Present, ma'am.
6. 6 not at present, right? 7.
Present, ma'am.
7001.
Present, ma'am.
7002.
Present, ma'am.
Okay. So absent is roll number 6 alone. Okay, thank you. Mhm. நீங்க தான் இந்த கிளாஸ்